All right. So we were actually talking about the examples of homogeneous mixtures. And then the other example is let's go. Oh, that's it. Let me check.
Sit down.
Yeah, that's it. So you can also think of other examples, right? You can think of other examples. So that's homogeneous mixture. Why is my thing not moving? Now, let's get to heterogeneous mixture. What does this term refers to? Hetero. Hetero means different. Homo means the same. Hetero means different. So heterogeneous mixtures, we say these are non or no uniform composition or non-uniform compositions. That's how you define it. Don't complicate your life. Just define them like this. Okay. So this have no uniform composition. Obvious is gonna be the opposite of homogeneous mixtures. So now here you can visually distinguish components. What does the distinguish mean? It means differentiate. You can visually differentiate components. You can tell, oh, what is this? You can tell, oh, what is this in the mixture, right? So now, sometimes heterogeneous mixtures, it could be in different phases. Sometimes it can be in the same phases. Okay, it depends. So let's have a look at examples. Oil and water. Have you ever heard of this phrase? Oil that never mixes with water, which is true. You can never, ever, ever mix oil and water. You can make a mixture, but they won't come out together. They won't react with one another. You will get to understand this as long as you continue with your chemistry when you get the university levels. Why? What is the exact reason why oil doesn't mix with water? Even in grade 12, there is pinch of that. If you are in grade 12 and you are a critical thinker, you will be able to understand that oil and water doesn't mix because of the intermolecular forces. So water is a strong hydrogen bond, and then oil is an organic compound. It's yeah, you don't need that. You don't need that for now. So just know that oil and water doesn't mix at all. Okay, that's what type of mixture is that? It's heterogeneous mixture. When I say doesn't mix, I want you to understand me. When I say doesn't mix, we mean that oil or water, it doesn't dissolve. Why oil doesn't dissolve in water or water doesn't dissolve in oil. That's what I mean when I say they don't. But we can mix them, but one of the liquid won't be able to dissolve in another liquid. They won't match. Won't be a puzzle. Won't be a yeah. And then another type of example is a muddy water. Like when you mix mud, when you mix sand or whatever with water, sand will start to settle at the bottom of the container, and you start to see the difference between the sand and the water. So you would be able to distinguish the components. You will be able to, there is water in this solution and there is a sand in this solution because sand will get suspended at the bottom of the container. And then sulfur and iron filings. Sulfur is like a yellow powder, sulfur. Um, when you take that yellow powder and then the iron filings, you know what are the iron filings? A grinder in your language, Sesotho guys, you guys normally call it the grinder. The grinder, when they grind the metal, maybe they want to install a devil's fork at the next door. So yes, that guys, they're gonna come and cut those steels. I get that iron. So the remaining of those cuts, we call them the iron filings. So when you take the iron filings and then you combine with a sulfur powder, would you be able to see what's happening in that mixture? Yes, definitely. You're gonna be able to, oh, these are the iron filings and this is the sulfur. So you can be able to see the mixture and you can be able to separate that on top of that. That's heterogeneous mixture. So this is Fe plus S. This one will be chemical. If chemically we combine them, it won't be, that's different. Separating oil and water, we can do that. So now the task was, please open up your mics. The task was we defined the mixture and we did an example of mixtures, right? We said we have screws and nails in a bowl can be separated by hand. And my question was, by the end of us learning types of mixtures, we will be able to answer this question. Screws and nails. Screws and nails, what type of mixture is that?
So isn't it the heterogeneous? I can't pronounce that.
It's okay, it's okay.
Hero whatever.
You're absolutely right. It's going to be
Hetero.
heterogeneous mixture. It's going to be hetero or
Okay.
heterogeneous mixture.
Oh, heterogeneous.
Yes,
Heterogeneous
heterogeneous mixture. Okay, that's absolutely right.
mixture.
So screws and nails, we are talking about the heterogeneous mixtures. Because you can be able to see the screws, you can be able to see the nails, you know. Awesome. That means you guys listened. So now, then, how can we separate these mixtures? How can we separate these mixtures? Can we separate heterogeneous mixture? Can we separate homogeneous mixture? That's the question. Remember, I said mixture, you should be able to separate them. It's either by physical means, it should be physical means, by the way. And this physical means, it could be a complex physical means or it could be a simple physical means. So let's see. So mixtures can be separated by physical means, like I said. So magnetism, you can use the magnetism to, this is an example of physical means. This is an example of separating technique of mixtures. You can use magnetism. It's a technique that you can make use of to separate the mixtures. Like what? If you have a petri dish, let's say we have a petri dish, it's a petri dish there, the dish in the lab. We put the powder. Okay, let me do it like this. We put the powder. Come on. We put the powder there. This is a sulfur powder, né? A sulfur powder. And then while we have a sulfur powder, let's assume that this is ion filings. These blue things, it's ion filings. How can you separate the ion filings from the sulfur powder? You know what you're gonna do? You're gonna take your bar of magnet close to this, based on the properties of sulfur and based on the properties of ion filings. Which one it has a magnetic properties. Sulfur, does the sulfur has a magnetic property? No, because it's a powder, right? And it's a non-metal. But iron, it has but again, iron has magnetic properties. So that means the ion filings will start to move from there to be attached here. They will be attached on this bar of magnet. And then behind, we're gonna left with what? With sulfur powder. So magnetism is one of the physical separation technique that we can make use of to separate the mixture. Another one is the boiling point. That is the boiling point. How can we make use of a boiling point to separate a mixture? This one is a bit of a complex. It's called distillation. When you distill salt and water, when you have a cup of water like so, here let's say the solution. What solution is this? It's water and salt. Can you separate water and salt? Yes, you can. By doing what? By boiling this water. I'm sure you guys know this from grade 9 for sure. By boiling water. So when you boil water, what's going to happen is vapor will evaporize. And then behind here at the bottom of the container, we're gonna left with what? We're gonna left with salt suspended at the bottom. So based on the this is just the distillation. Another way of this separating, let's say we have an alcohol and water. When you boil alcohol that has water and alcohol, they have different properties. Water can boil at a certain temperature. Most of the time, at the standard temperature and pressure, let's say maybe at the standard pressure of uh, above sea level, 1 atm, 1 atmospheric pressure, or 101.3 kilopascals. So when you boil water and alcohol, water will boil at 100 degrees Celsius. So water will escape at 100 degrees Celsius. Maybe alcohol needs more than 100 degrees Celsius. I'm just making an example. Maybe for alcohol to boil, it needs 150 degrees, or let's say it needs 200 degrees Celsius. So meaning when I boil this solution, I'm going to boil it at 100 degrees Celsius so that water can evaporate first. And when water evaporate, and then I will cool my water at some point, or condensation will take place, and then water will collect in another beaker. Water will come maybe to this side. And then what's going to remain behind in this beaker, we're going to left with alcohol. Why? Because we subjected this beaker into a temperature of 100 degrees Celsius. So we know at 100 degrees Celsius, water is the one that's gonna boil. It is the one that's gonna evaporate. That's the boiling point of water. And when water goes out, what's gonna left behind? It's alcohol. Why alcohol is behind? Because for alcohol to evaporate, we need a temperature of 200 degrees Celsius. So we know that based on these two solutions, based on these two substances, water can boil at 100 degrees, alcohol can boil at 200 degrees. So if we subject this to 100 degrees Celsius, only water will escape. Alcohol will remain behind. So that's another technique of separation. And you will do these things, more especially when you get to university. This is what I most definitely do. We do the distillations. We separate oil and we take crude oil, we separate it into paraffins, we separate it into petrol, we separate it into kerosene, that's the basic idea of a chemical engineer who works in petroleum industries. Okay, so yeah. I talk too much. So mixtures can be separated by physical means. Another physical means is solubility. It's solubility, right? The one that is solubility means which one is soluble in which. Okay, so don't want to talk and waste much more time over here. Okay, now, so how could the following be separated? Let's have a look. Sulfur and iron filings. Anyone who wants to answer this question over here? Tatenda, let me give it to you, my king. So how could the following be separated? How can we separate sulfur and iron filings? Which separation technique can we make use of?
So I'm going with magnetism.
Come on now. That's absolutely right. We're going to pick the magnetism, right? That's how we can separate sulfur and iron filings. And then let's talk to Tato. Tato, say my name, baby. Tato. How could the following be separated, water and alcohol?
Sir, I think either boiling point, sir, or distillation. I'm not sure, sir.
Yes. Boiling points. Okay, let me put it like this because you guys are in grade 10. Yeah, even distillation. It's either boiling point or distillation. You are absolutely right, because distillation is a separation technique. Whether you separate what or what, but you separate based on the boiling points. Distillation works based on the boiling points. We separate the more volatile compounds. I get the more volatile compounds. I mean the one that can evaporate at the lower temperatures. So if water can boil at the lower temperature compared to alcohol, then that's a distillation separation. It uses boiling points. Distillation uses boiling points. You are absolutely right. Thank you very much. And then we can use distillation, by the way. Kauhelo. How could the following be separated? Muddy water.
Solubility. Solubility or something.
Okay. So okay. You mean solubility, right? Did you
Yes.
think of filtration? I think you guys did this thing in grade 9. Filtration. Do you know filtration?
Yes, using paper.
But again, I think it's a litmus paper or something like that. You can use, yeah, there are many techniques of how you can run it. It's either you use your litmus paper or you use your sponge, there are many different techniques. It's just that the other one will be more effective than the other. Okay. Yes, litmus paper is used for acids and base, but you can also use the litmus paper for separation at the funnel. The funnel, I get you guys design artificial funnels, blah 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 blah. So remember, you have a funnel, you have a cotton, you have sand, you have, man, we used to do these things in grade 9, and then we put the muddy water inside of the funnel. Funnel, I don't know how to draw shame. There must be, there is a sponge here, something like that. There is a sand, fine sand, what. And then here's the container that has muddy water, and then here's another clean beaker. When we put that muddy water into this filtration, then it will go there, and then we'll see the drops. Boop, boop, boop. We'll see drops, and these drops will start to be clear instead of the muddy drops, but it won't be 100% effective. But yeah, this is another way, another technique that we can make use. That's why here we said etc. We can also use filtration. We can also use filtration. Yeah, have you ever thought of that, Hello?
No, sir, it is not in my mind right now.
And it's not in your mind, né? Yeah, we can also use this part, okay? All right. Which companies we can go with for solubility as well. Thank you. And then how can we separate this one? Nolutando, salty water. Which technique can we use?
Boiling point.
We can use, okay, let me put it like this now. Yes, we can use the boiling point. You are absolutely right. We can boil, by the way. We can boil the salty water. But most of the time, be careful. The boiling point part, we use it for liquid. When you have a liquid water, liquid alcohol combined together, we separate that. Most of the time, we use the boiling. But for salty water, we can use the boiling, okay? But the most effective way that we use, it's that distillation that does not use the boiling point. It is the distillation of boiling and condensation. We just boil water, and then water will condense. It's something like this. Let's say we have some sort of a volumetric flask in the lab, and then here we have a solution, and then here maybe we have a stopper, we have that pipe. There's a pipe here, and then this pipe, this is a condenser. And then this condenser here, it has pipe inside of it. It's called the condenser. And then we have a beaker over here. So what's going to happen is we're going to subject this volumetric flask into a heat. We're going to heat this volumetric flask. We have salty water. So when we have a salty water, what's going to happen is we boil this water at its boiling point, and then it will evaporate. So the steam will go up. And then when the steam gets into a condenser its temperatures are very low, so it is cold. Just like when you boil water in a pot, you will see at the top of the lid, at the lid of the pot, you're gonna see water, uh, um, the water droplets, and then we say that's entrainment. Entrainment, it's, yeah, something like that. So meaning water will evaporate and attach to the condenser, and condenser will cool off the temperature of the heat. And then when the heat cools down, what's going to happen is condensation will take place inside of a condenser. And then when that condensation takes place, the steam will turn into a liquid, and that liquid will move down into the beaker. You're gonna see the droplets, then we're gonna have pure water, and then at this point in time, we're gonna have salt remaining behind. I think this kind of explanation, if you check your textbook, study and master grade 10, you'll find something like this. If I still do remember, you'll find something like this. That's how you can separate salty water by distillation. Or yeah, okay, awesome, guys, well done to you all. Yes, and then nails and hand screw all together. Which separating technique can we use? One, 2, 3. Say it.
Magnetism.
I don't know. I don't know. Okay, nails and screws. Which separation technique can we make use of to separate nails and screws?
Magnet.
Hand separation, sir.
And remember, because both of them, nail and screws, they have magnetic properties. So if you have a bowel that has nails and screws, and you put both magnet, what's gonna happen? Anything will go, whether nail or screw will go to the magnet. Babo. So nail and screw, we're gonna use the hand. It's simple, this one. But iron fighting and powder, you can't use hand. You might as well, it's gonna be too much. Okay. I hope that was clear. Babo. It's nice when we talk all together because we can see our mistakes and fix our mistakes.
Why did I have magnetism in here? Nails are screws.
Oh, hello. When are you love? Forget you, your mic is open there. All right. All right. So now that is what we call chromatography. My grade 10, we did chromatography. I don't know why most of you guys don't do chromatography. I don't know. Maybe you guys next this year you're gonna do it, or maybe some they've done it. But I've realized a lot of students they no longer do this experiment. When I was doing my grade 10, we did chromatography. Chromatography is a separating technique as well. But you know what does a chromatography separate? You see the marking pen, the black marking pen that thing, that ink inside of the marking pen, it is made up of different colors. Did you know that? It's a black marking pen. Inside there is red, there is blue. Well, it is made up of different inks. A black marking pen, it is made up of different colors. There is blue, there is red, there is yazini. Vingivongo. For sure you didn't know that. We did this thing in grade 10. Oh, it was so amazing. We could see different colors inside of one color. So chromatography is one of the technique. So you know what is the chromatography used for? For crime scenes. For example, Tato wants to kill Gauhelo. So Tato this is Tato would do, ne? Tato would take his pen and write a note that threatens to kill Gauhelo. And then Gauhelo will be like, Tato threatened me, and then she wrote the note that she's gonna kill me. She takes the note to the police station. You know what crime investigators supposed to do? They're supposed to use chromatography to catch the person who threatened Gauhelo with that. So they're gonna take the note and they're gonna run chromatography on that note. And they go to Tato's place. When they get to Tato's place, they want all pens that Tato uses. And then they will take all of those pens without telling Tato because they know Tato will throw the pens away if she's mad. That's another way of catching a thief who threatens people through the notes, through the note, like when you write down. So they will take Tato's pens and then they will run chromatography. If they match the chromatography of that Tato's pen and the chromatography of the note that was received by Gauhelo, that if that corresponds, then they're gonna be able to see, wow, you're the one because this is your pen, and you're the one who wrote this note. They're gonna see who wrote that note. So it's fun, man. It's nice. So we say chromatography, this occurs when ink is separated into different colors, making up the ink. A black color, it can be made up of red color, blue. This is amazing, man. This is weird. We didn't know that for sure. So this is a setup, ne? This is what you used to do in grade 10. We will take different markers. A black marker. Let me zoom there so that you can see. We will take different markers, ne? A black marker, maybe this is orange, this is red, this is green, and this is pink. You know what we're gonna do? You can even do it. I think I have chromatography papers here. Guys, I'm in Bethlehem. If you want them, you can tell me. I will give you guys so that you can do this practical. It's nice, or I will shoot a video and then I will send it. I will post it on YouTube. I'll send it to you. This paper, ne, it is a parking elite. It's a filter paper, by the way. It's called the filter paper. I think I have them. So, and then you take a pencil, you write a faint line over there, and this is a black, different markers ne, with different colors. And then you put a little bit of water. Make sure that that water, it touches the bottom of the paper kancane so, ne? And then this is a pencil, and this is a translucent cup. Then now what you're gonna do is, this is absorbent paper with ink mark, or you can say a filter paper, whatever paper that you want to use. And then this is a solvent, mixture of ethanol and water. So you need, oh yeah, you need, but I think we use the pure water. I can't remember. I think we, but here for effectivity, you need ethanol and water. Hi, what's happening now? Are you able to see, guys? Hello?
Yes, it's a
Yes,
vacancy.
sir.
Oh, what's happening with my, oh, okay. Ethanol and water. Okay, ethanol and water. So this is a mixture of ethanol and water, and then the different colors travel through the paper at the different speeds. You know what you're gonna see when this water, I get what this thing, it absorbs water. This paper towel, it will absorb water. So water will go up, ne? This water by capillary tension will go up. And when it goes up, you see this black ink, it will run, it will run, it will run. And then when it runs, it's gonna leave different colors behind. Even this one, Babo, let's see. These are different effects. You see, there is a red, there is blue, there is a greeniana, and there is yellow. That time, this thing is started as a black ink. You understand? So you can also go to the net. Let me do this to make things hard. Do this to show you something. Ish, my PC, my PC. Let me do this to show you something nice there. Okay, I'm gonna show you something nice there. Let me do this. Okay, I pause the recording, so it doesn't be, so that this doesn't become long for no reason. Oh, Jehovah. Oh, laptop, yeah. Aish. I'm gonna use my other laptop because I came here to fetch my other one. I wanna see if that one, that one is slow. I wanna see something about it. Let's see. Hey, come on. Oh, Jehovah. Hey, Tato.
Sir,
Rekele laptop batho le bo gauhelo ka za tamo le botatenda le bothando le rekeleng laptop. Eh,
sir, ich will still students, sir. Today.
bathong ka zatang ay. Ke a tseba nna na le tšhelete e ngata hampe. No, I'm kidding, man. I'm kidding. What do I want, Konji? Oh, I want to come here. My laptop has been working, guys. I have something that I need to submit tomorrow, and I'm not. I haven't even started. I have a lot of work, Shay. Ooh, okay, come on. Autography. Show you something, guys. Okay, let me do douche. Hurry up. Laptop, please don't do this to me. Okay, let me see. Yeah, no, I think it is now sorted. Mm. Oh, high slow, cake. Okay, let me share the screen. Oh, only get laptop one is. Yeah, yeah. Hey, why?
This video shows an example of a chromatography experiment.
Wait.
The goal of the experiment is to separate the different pigments of ink which are present in a wet erase marker right here. So a vis-a-vis marker is wet erase, which means that the pigments are water soluble. We'll start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This
Okay, I'm gonna start this.
shows
Are you guys able to
example
see
of a
the screen?
chromatography experiment. The goal of the experiment is to separate.
No, sir.
No, sir.
No. What's alarm? Sakazi sabuni. What do you see on the screen right now?
No, sir. So it just says Tapo Mokoena has started seafaring, sir.
That I don't. What's alarm? Oh God. Ish. Okay. Oh, do I need to close the program? My laptop, guys. Screen. You are able to see the screen, I guess. Keep remembering. Are you able to hear the sound? Okay, just watch. You see the markers. They're using the black markers and the white markers.